And without further ado, let me go ahead and introduce, and I'm not just saying this. These are two of my dear friends, not only within the T Cube community. T Cube, again, teachers teaching with technology. You all know that. Two dear friends of mine, whether we're doing T Cube things or whether we're not. And these two young ladies are Jessica Cahoot and Stacy Thibodeau. Jessica lives in the Baltimore, Maryland area, and she'll do a brief introduction during the at the beginning of our video and beginning of our recorded session. And Stacy Thibodeau lives in Lafayette, Louisiana. So we have two people with very diverse backgrounds bringing this together to do a common session on coding and STEM projects. So without further ado, let's turn it over to Bravura and let's get started with this session.
Hi, I'm Jessica Cahoot, and I am a biology teacher at Reservoir High School in Howard County, Maryland. I'm also a T-Cubed instructor, and I'm excited to talk to you today about coding and some STEM projects.
Hi, I'm Stacy Thibodeau. Thanks for joining us for this virtual conference. I am from Louisiana, where I teach Chemistry 1 and Chemistry 2, and I have the pleasure of having a robotics class this year. And like Jessica said, we're excited for you guys to be here. So a little bit about why Jess and I do what we do. I'm gonna talk about what I do in my classroom, and then she's gonna talk about what she does in hers. Why should you introduce STEM and coding into your classroom, no matter if you have a traditional math science classroom or you have a STEM classroom? For number one, for me, is going to be collaboration, allowing students to work together with others, but also in a real world situation. I remember being at a conference once and the presenter mentioned the fact that we are preparing students for jobs that aren't even available yet. They haven't even been thought of. And so if you look at the occupational outlook for the next 10 years, the number one skill is coding and or some type of programming skills. And so that's definitely why I added in my classroom. Jess?
Yeah, I am, well, as I said before, I'm a biology teacher. And so when I first got introduced to the possibility of having my students do coding in the classroom, I was very skeptical at first. But I realized the importance of allowing students to explore and create and just giving them the exposure to understanding a programming language and seeing what it can unlock for them. And it's been such a transformative process in my own classroom of being able to see students be successful in skills that they never thought they would have been able to do before, and just let them see science in a different light by having this exposure to coding and engineering design.
Exactly, yeah. And so another big topic for Jess and I is this critical thinking, and having STEM projects and or coding in the classroom allows the students to have to troubleshoot, have to solve problems, use mathematics skills and their science skills in these real world situations where they might not have had access to it if we were just the content deliverers. Both Jess and myself put the coding into our traditional content classes. And that's what we want to share with you guys today, is how our story came about and how we started learning how to do coding. Neither one of us said we were computer science teachers, and so how did we get started with this? And then also share with you some of the projects that our students do in our classroom, and then also give you guys some resources that Texas Instruments has to give you more information on how to put this into your classroom.
And so where we started was the 10 minutes of code that TI has put together to really help you get started. I have no coding background. 10 minutes of code is where I got started, and it's an easy, accessible website that you can go through and find the information you need, learn step by step what you need to do in order to make your programs work. It's something that I did before my students each time. So I would do the 10 minutes of code, introduce it to my students, and we would really learn together. And that was a really important process for me to kind of let go of, as teachers, we kind of want to know everything, and we want to be able to share with our students that, you know, we know what we're talking about. But we kind of have to, as I introduced this to my students, I had to take a step back and be a little bit humble and have them show me a lot of things and learn together. And it was a great way to kind of connect with my students and learn with them, and see them grow and see them excited about what they were experiencing and learning along the way too.
Yeah, so I too did the same thing. I started with, as a T-Cubed instructor, one of the things they talk to us about is the Computer Science Week and 10 minutes of code or coding with the hour, different types of weeks. And so that's where I started a couple years ago, is introducing 10 minutes of code on a Friday. I had just gotten the Inspires, and so I was learning at the same time the students were. And it was fun, it was frustrating, it was frightening, but we all got through it. Jessica, like she said, is in Maryland, I'm in Louisiana. We can't just run down the hall and ask each other if we have questions or concerns about the projects. And so finding a buddy out there is definitely worthwhile if you're trying to start these projects. But having access to the 10 minutes of code, there's teacher documents, there's student documents, the programs are given to you in the document, and then also ways to help troubleshoot. So starting like Jess and I did, both of us with very little to no computer programming background, having just access to the 10 minutes of code documents made our lives a lot easier when we were trying to do this with students.
Yeah, it's very step by step. And even just the process of coding with the calculators, it's menu based. So students don't have to memorize a bunch of syntax. Once they kind of get into the menu, they kind of figure things out. And we'll show you some examples of that too. So it's kind of a nice in between of kind of the drag and drop kind of coding that students might have been initially exposed to something a little bit more complex. So it's a really great stepping stone for students to kind of get involved into programming. And plus, everything is built in. So we'll go into these STEM projects that, again, are step-by-step that really help you get involved in that engineering design process. And as Stacy's robotics class that I'm so jealous of that she has, of getting into the rover and being able to think of those logical steps that will just help students be even more creative.
So on this slide, it talks about the different handhelds calculators. And so depending on what you have in your school system, Jess and I both have the Inspire CXs. So we're going to use the TI Basic mostly in this session today. But you can also use the 10 minutes of code if you're an 84 plus CE. Like I said, Jess and I are Inspire users. But recently, a couple of months ago, TI released the CX2 handheld that has Python programming. And I'm going to talk to you a little bit about Python programming. And this is where I'm getting started. I'm spending some Saturdays watching some videos, standing with the 10 minutes of code, learning how to code and program with Python, because that's also not in my wheelhouse, but I'll learn how to do it just like my students will. Jess, anything else you want to say about 10 minutes of code?
Just that it's just a great way to start. So if you're not sure what to do, 10 minutes of code is where you're going to dip your toes in.
Absolutely. All right, so I am going to show you kind of just what we wanted to be, traditional teachers and kind of model an effective lesson for you guys. And so I'm going to show how you can use the 84 CE coding. I'm going to use the SmartView software. Jessica's going to show you guys the Inspire, how you can do the same type of programming on either. And then we're going to show you how it's, like Jess said, menu driven. The button pushing is very minimal once you and the students figure out where to go. And also at the same time, it gives you some opportunity to grow and learn from some of the coding. So I'm going to show you how to do our first program. This is the first program all my students write. Most students in a programming class write a hello world. So this is the SmartView software for the 84. Like I said, I'm an Inspire user with my classroom, but lots of different workshops and stuff that I do with TI, we use the 84. And so this screen, I would project this for my students, have my teacher computer plugged in. My students would all have their calculator or handheld, and we walk through it together. This emulator software does allow for when a button is pressed, it changes color, and so it's really easy for a student to be able to see. And so Jessica mentioned it's menu driven, so we're going to create a program, and it's under PRGM. You can see all of the programs that I have already created in here. I'm going to move and use the cursor, the arrows, to go and create a new program. One thing when you're using your computer for the showing the students, you have to use the same keys. And what I mean by that is you can't use the keyboard letters, you have to use the alpha characters on the actual emulator. And I learned that the hard way. We'll go create a new number 1, and I'm gonna call this Hello World. And I'm going to put it all in caps. So there's a few, I guess, tricks of the trade with learning how to program and code as far as what the program language requires, but also what is user-friendly. I'm just actually going to call it hello, and I'm going to hit enter. And so there already had a program named hello. On the 84, you have to insert a line of code called clear home, and that way you start out with a fresh screen and nothing is actually there to start with the actual program. And so for a hello world program, all it is a display statement. So I'm going to show you guys how I got that. So under program, now it looks different. A while ago I had execute, edit, and new. Now I'm in what the menu is for the actual program. And so these are all the different types of loops or control statements that I can add. We want what's called an IO, and IO is an input and output. And so I'm gonna just arrow down to the number 3 for a display. And notice it's in quotes. And so that was one of the things I was talking about with programming language. Having things in quotes allows for the calculator to understand that it's an actual command and it's going to go and execute it. So I'm going to go hit the quotes. And again, I'm going to add my hello. And then close quotes. And I'm done. So when I want to execute it, I like to second quit and get out of that menu. The program is automatically saved. That's really nice for the 84. And I'm going to execute. So this was the menu I was talking about a while ago. Execute, edit, new. I'm going to go execute my hello. And if I hit enter, it says hello world because that's what I had saved originally. And then I just typed in hello. And that would be a first program. If you were trying to input this into your math or your science class and you don't want to take away from your content, it didn't even take 10 minutes for me to do this with students. So definitely an easy way to get students into understanding some of the programming. So that's our first program we wrote. I mentioned I teach chemistry, and so in chemistry, especially my chemistry 2 class, we use a lot of formulas constantly for the same types of problems. And so in the 10 minutes of code, one thing that you can do is program the calculator to have the formula already there ready for you. And so the students can actually see and execute it if they wanted to use it multiple times. And so this is just a program that I wrote real quick. In the 10 minutes of code, the program was to find the hypotenuse given 2 of the sides of a triangle. I just edited it to calculate the concentration, the pH given a concentration of an acid. And so just a quick, easy way to add a code or a line of code that was edited. I could change it and maybe add a different calculation if I were interested. So that's coding, introduction to coding, and I would probably start with something like that with using the 10 minutes of code, and this is was on the 84 CE. Jess?
And on the Inspire, it's very similar. And I do something very similar with Stacy, where this is the first thing that they use. So they have handhelds in our classroom. They have the Inspires. And so just to get them used to the menus and what they can find on the menus, I use the Hello World with them as well. So I project on my screen the teacher software, and I walk them through the same thing of finding the display. So this is the teacher software for the Inspire. And from here, we're going to start a new document. And in the new documents, there's lots of documents that we can choose. In this one, we're going to pick 9 for program editor. And you can also see there's the Python program as well, which we won't necessarily do this time, but as we learn more, maybe next year we'll do a Python one, right, Stacy?
Yeah.
So very similar to the 84, we're going to add a new program, and we can name it just like we did before, Hello, or Hello World. Either way, it's easy. I usually try to go small, shorter, the easier. The Inspire has an alphabraic keyboard at the bottom, so you don't have to hit the second alpha. But even my students who are whizzes at texting have issues with the alphabraic keyboard. It slows them down a bit. They get really quick with the more practice. And so with our Inspire program, we have our program and M program in this box that flashes, and that's where we're going to write our code, our program. And so if we're in that box, we can hit the menu key, and that's going to provide us with all of the information where we want. So just like in the 84 menu, we had our IO, our input output, and I'll have my kids guess what I and O stand for before telling them, and most of them can figure out it's input output, especially some of those kids that have a minimum coding experience. And that's the display command here too that we're going to select. And then we also need those quotation marks to put in what we want to say. So here it's the control and multiplication sign to get our little box with our quotations, and we can type in our text of Hello World. And so when I do this in the classroom, I have the navigator system, so I can project it onto my LCD projector, and I have them write a school appropriate phrase that I make sure I check before we launch it off and show everybody. So it's for some of my students, this is the first line of code that they've ever written, and they feel really excited about it. And it does take 10 minutes. And, as Stacy was mentioning, in the classroom, it was like STEM Fridays is what we would have. And so our warm up would be some sort of coding or engineering design project or part of a project that we would build up to. And it was always lots of fun. And then to run our program, because we're not done yet, we have to hit one of the shortcuts is Control R, or we could hit the menu, which Stacy likes to do. I like the shortcuts.
Stacy's not a shortcut girl.
So Control R would be the shortcut, which is where you would, I tell my kids, R stands for run. And so Control R will bring up a calculator page with our program name, hit enter, and we run our program. So Hello World, and that's our program. It's so easy for students to, for kids that are very apprehensive to try something like this, they feel very comfortable. It's very easy. They can find easy success with something like this. And just like Stacy, I adapt the 10 minutes of code to my own personal classes. I teach biology and AP biology. And one of the things that we have are these formula sheets, and we use the formula sheets to find solute potential. So that first skill builder and 10 minutes of code, finding the hypotenuse, I show that to my students. We work through it. We typically do this in a normal year during that computer science education week, so that we get some practice throughout the week. And our finale project is taking a formula from that formula sheet and adapting it to writing their own equations that they can program into their calculators and save it for later. So in this one, we changed it slightly. So in the 10 minutes of code, has a little bit of different instructions, but my students wanted to get information. So they explored this request command so that they were asked to input information. So we wanted to know, like, we would have our ionization constant, we would have our molecular or molar concentration, we would have our temperature, and then what this display would then be that calculation for it. So they're inputting those values that they know, and then the calculator is going to do all the math for them based on the program that they just wrote. And it was just so simple, and they're like, oh my gosh, I don't have to do anything, I just have to put my values in and it's done. And they just thought they were like the smartest things ever. And they're like, I'm going to save this for later. And they were very excited. Just
Well,
easy.
because they actually see and understand what the formula represents, and that it's not just plug and chug in a calculator, but they also have, they're also excited because they did something with it. It wasn't just plugging and chugging and spitting out an answer. It meant more to them. I know, at least for my students. I'm sure yours too, Jess.
Absolutely.
All right, so after we started with the 10 minutes of code, just like for the Computer Science Week and having fun Fridays, I wrote a grant and got several of the TI Innovator Hubs. And with this TI Innovator Hub, it's a microcontroller, and we have a bunch of different projects that use it. And this microcontroller is housed in a box, and it has input and output ports. It has a built-in brightness sensor. It has built-in lights, a built-in LED, RGB LED, and it also has a built-in speaker. And so with this, we were able to then take the applications that were part of the 10 minutes of code. And so there are 10 minutes of code, not just with programming and the formulas and learning what a request and a display and an if-then statement, but now using the Innovator Hub 10 minutes of code. Same thing, starting small with the students. This is how Jess and I learned, sitting with the Hub at our houses, talking to each other through text or whatever, learning how to use the different commands that we did with the students, now how it applies to the Hub. Same thing, there are skill builders that walk you through. It can be a 10-minute day, can be an hour class. And then there's applications. This is both for it's actually for all, it's getting to be for all three, but both for the 84 CE as well as the Inspire. And so what my students, the first of the projects of this using the Hub is to build a traffic light with sound for when it's safe for a blind person who can't see the traffic light, when it's safe for them to crosswalk. And our local university has them, so our students know, they kind of have an understanding of what happens. And so on the 84, it's going to look exactly the same as what Jess has. And so what we have is, this is a color. That's for the RGB LED. RGB stands for the red, green, and blue. And so there are 3 values that either you can request, like Jessica showed with the request statement, or just have built into the program. So my students, we're going to make it red first. And so this is a value from 0 to 255, 255 being max, 0 would be none. And so I tell my students there's like 3 prongs on it, and I'm sending electricity 0 to 255, 0 to 255. And if I wanted blended, then I could do blended. And so this first one is, it's a red light, and we set a sound. And so the speaker that I was mentioning is built into the Hub. So it automatically will send a sound, and for a specific amount of time. Students love this part of the sound. They like playing and doing music. And then after the sound was heard, then we set the color to be green. Then we set the color to be yellow, and then it's cycled throughout. Jess?
And so with the Inspire, so this is the Inspire version of it, and we also did this as well in our class, and I'll introduce it with, not just even with the traffic light yet, but when I give them the Hub, I show them how to use the RGB, the set color, and have them play around with what those values mean and try to have them figure out what the 25500, what color is what, and then have them, you know, a lot of them are very excited about that. And then we give little challenges like try to match the color to your shirt. And, you know, they find that very silly and fun too. And so as they get comfortable with what those menu commands are, we follow the 10 minutes of code. And so this is a variation of that, where they now are introduced to for loops. And they've taken the information they learned from the 10 minutes of code and added more to it. So they think about what they want, how they want the program to work. So they don't just want the light to turn on and then turn off and then stop. They want it to continue. So they created this for loop so that it could repeat a certain amount of time. And then if they wanted sound, they could add that in. And so they get very comfortable trying things out, thinking, oh, well, I want it to do this. How do I get it to do that? And then thinking about what information they need to put in. So that logical thinking is just becoming, it's forced naturally, and they actually enjoy it. And it's a problem that they're really interested in trying to solve. And it's, as a teacher, it's wonderful to be able to see them struggle through that, but in a positive way where they're not just giving up. They're like, I need to fix this. I need to make it the way that I envision it. And it's such a powerful thing to see. It's awesome.
Yes. One thing that was frustrating, I know, for my students was the fact that they know the red light, green light, yellow light has different times built in. And so these weight statements, if you notice, the weight statements are different amounts because we wanted them to kind of match of what happens with a real traffic light. A project that I did last year with my chemistry students is when we're studying about electrons, the overarching phenomenon that I use is about fireworks. And so why do fireworks work the way they do with the different colors? And if you know anything about chemistry and those types of classes, we do what's called a flame test lab, where we actually take a metal salt and put it in fire and it makes a color. So my students designed a firework based on the colors they wanted, but they used the hub and this RGB LED to be their fireworks. They didn't really make a firework, but we did it in a simulation, and they had a lot of fun. Some of the students who were more advanced and had some type of programming skills before got it done a lot quicker, and they wanted to add the sounds. One of my students even took a hub home and his own calculator, and you did the Super Mario Brothers theme song, and came back in a couple weeks with it on. So that was interesting because that wasn't part of the lesson, but he was excited to share it with us on what he did.
Yeah, it's amazing to see how your students can really take something so simple and really run with it. And I don't read music, and I have another instructor created a correlation between the frequencies that the hub put out versus musical notes. And I shared that with one of my students who was in AP music theory, and she was able to take the hub and a calculator and code her music that she was auditioning to, and she did it in like probably 15 minutes. Like, never really had experience with it before, but kind of was able to figure out how the notes worked and the length versus the frequencies, and was like, okay, let me play this for you, Miss Kahoot. And I'm like, oh my gosh, how did you do that? So
I didn't teach you that.
I know.
That's the other thing. I didn't teach you that. You show me what you learned and how you did it.
Right.
One thing that's really cool that Jessica mentioned was the navigator aspect of the Inspire. And, if you have, like I do, the robotics class, or you're trying to build, in Jess and I's content specific classes, every Friday, maybe build on a skill, and we want them to build on a program. If a student is absent, sometimes it's hard to play catch up with them. So through Navigator, I can actually send a file to a student, and then have them maybe manipulate it or use it for the class period and not waste class time, but spend class time catching them up with the syntax of it, but then maybe have them just have the program and then use it. For my robotics class this year has been crazy. We all know as classroom teachers, students in and out, going virtual. My schedule is AB hybrid. And so I've had students come in the middle of a 9 weeks. They had 0 to no coding experience on the Inspire, and I was able to catch them up in 2 days by being able to send them the files. They saw how it worked in the hub, and then they were able to go, and they're all caught up. Even though they missed, class time and the building of it, they're all caught up because I was able to send them the files.
And that's been really helpful too for the STEM projects, which get a little bit more complicated in the code. And as a biology content teacher, I don't always have the time to really get into the code and make my kids experts. But what I really try to get my kids to be able to do is to interpret code, at least the code that we're using, so they understand what the code is telling the calculator to do, and have them think logically of what they want to do, what the program needs to do. And so if they can interpret it and then modify it to get kind of that base to do what they want to do, they can still be successful rather than write everything from scratch. And it kind of at least is a time saver in a content class where it's more of the product that we want to kind of showcase, but giving them some help along the way with the journey of being able to interpret and then modify to get what they want.
Exactly. So Jessica has mentioned STEM projects. And so this is kind of the evolution of Jess and I. So we started with 10 minutes of code in our classes. We actually went to an international conference a couple of years ago and went to a session in one of the projects Jess is going to show you. And we really had just kind of met each other, huh, Jess? Like that was our meeting, yeah. And so we sat at the table together, and we both got excited about how to not only just do the 10 minutes of code and build a few, programs here or there, but pull projects into our classrooms. And then here comes STEM projects and all of the different types of projects. So I'm just quickly show you guys the website. The STEM projects website has a lot of information on it as far as how to get started, who to contact for more, but it also has all of the documents that you're going to need as far as if you're using the 84 or your Inspire. We'll talk in a minute about Python for the digital mood ring. But these are projects that you could start with your students, either have, group 1 do one part, group 2 do a different part, and then come together. Or if you had enough kits, or if you just wanted the students to program, each group maybe has a different project and then we share. Or if you're a content specific teacher, and Jess is going to show you some of the examples she does, how she pulls the STEM projects and puts it into her curriculum. And so these are different activities that you can click on and then have all of the documents available for you as the classroom teacher. TI makes it so easy for you to actually do this in your classroom.
Yeah, absolutely. I love every part of all of this.
So like I said, Python is the newest programming language. It's used on the CX2 handhelds. Python does have its own 10 minutes of code. And so Jess and I also talked about that's going to be our summer project, really diving into it next summer to make sure that we can pull it in for our next school year with our students. We're familiar with the TI basic language. So now if the 10 minutes of code is parallel to the basic language for the Python. So now Jess and I have in our minds, okay, we know how to do 10 minutes of code with our students and the projects. Oh, now I can go do the same things and have a basis now of coding language to go learn how to do the Python. And then the STEM team, TI actually has a STEM team that's working on all these projects, is helping us, and I say us, all of us, figure out how to do these STEM projects that we've done with our students, but do them in terms of the Python.
Yeah,
and so
and Python,
I'm sorry?
Python's a really applicable language for students leaving the classroom, having a very valuable skill of being able to program in Python, if they can leave the classroom with that, that will definitely help them immensely with their resumes and potential job prospects in the future.
So I stumbled upon this, even though I'm a T-Cubed instructor. I didn't know this existed until about 2 weeks ago when I started investigating a little bit more about Python, is that they have a entire channel, a YouTube channel for the STEM projects, where the STEM team is walking you through how to do Python programming, but also with the STEM projects for different ones that they have. And so I actually started watching some of these videos and self-teaching. That my goal for the spring semester, probably about February or March, is to start trying some of these Python programming STEM projects with my robotics students. So that's my goal. So I wanted to make sure you guys knew, if you're interested and you have the CX2s, that there is the basic, but then there's also Python. Jess and I are going to share some projects that we do with our students, but we're using the CXs and TI Basic. So my robotics class, I'm just like so thankful. I love my principal. I went to her 2 years ago, wrote another grant, got more innovators, more innovator hubs, and the kits that are associated with it. So you'll see in a couple of projects, there's what's called an IO kit. It's an input output that has extra input and output materials that you can build for other projects. And she was like, what are you going to do with that? So I started a STEM club. And so I had a STEM club that met after school once a week. We met for an hour and a half sometimes. And it just started to get where students were in track, and so they couldn't come on Mondays, and so I had to change it. Or they were football players, but they wanted to be in STEM club, or we just were running into issues. So last school year, we had a skinny period built in the day that was for tutoring and or remediation or just kind of study hall. So I had a STEM class in there. Well, that was only 30 minutes. And so 30 minutes worth trying to just get everybody in, get all the materials out, and then like it was time to leave. So I approached my principal and I was like, hey, what about an introduction to robotics class? And she was like, explain what you're going to do. How much is it going to cost me? And I was like, it's not going to cost you anything because I already had everything. I did have to purchase some rovers, but I wrote another grant for that. And so I have 27 students. We're alternating days, so I don't have them all at the same time. And they are just having so much fun. It's all boys. There's one girl. I have both freshmen and juniors. 2 of my juniors were in my STEM club. They're freshman and sophomore year, so they kind of have some background information. But the freshmen have no background information in coding, and they just thought it would be something fun. So I'm so thankful that I actually get to have this course and still have fun with students, and it not be it's hard in this. If you're a teacher, you know it's hard in this pandemic, and sometimes kids just need a release and it not be a graded assignment all the time. So I'm going to share with you a couple of projects that I did with my students. So this is the TI rover. I'm going to let it play real quick. And so the rover is Texas Instruments kind of like on-ramp to a robotics program. That's why I called my course Introduction to Robotics. I'm not ready to go and do robotics competitions, but this robotic vehicle does have the availability, which you just saw. There's a pin that you can add to it. I use an expo marker, and we were drawing different shapes. And so students had to understand a little bit about geometry and the lines of code that were specific for the types of turns. This week, we started working on the front end of the rover. It has a sensor that's a range sensor, so a distance, an ultrasonic distance sensor, you can say. So kind of modifying what we see with our vehicles and the backup sensors and cameras. And so they're learning how to take the data that's received from that and then change the path of the rover. Next 2 weeks, because this is pre-recorded, we're going to do some Christmas tree stuff and add some lights and sounds, and maybe, I don't know, make a store on top of a Christmas tree or something. I don't know, have fun with it. that was Rover. This was the introduction to the traffic lights. And we had a first responder day on campus where our student resource officers and some of the local firemen came on campus. They were really just here for beginning of the school year safety stuff. And so I was like, let's do something fun for them when they came by. And so we did some police vehicle sirens, just using the program of the language using sound and the RGB LED. But still, it was exciting because the first responders felt appreciated, and at the same time, my students got to showcase their project.
With the traffic light.
With the traffic light, yeah. This is an automatic dispenser project. So with the hub, there is a built-in brightness sensor, and the brightness sensor will sense light levels. You could add an external light level input sensor, and it uses an output of a servo motor. And so now students had to take input information and create a program that would then have an output. And in this case, it turned a motor for a dispensing of, it was beans, because I could throw the beans away. I didn't want to waste candy on that. And so this one was heavy on the engineering design part, the engineering aspect of it, because not only did they have to have some type of functionality, but we didn't want all of the beans spilling out at one time. And this student actually put some lights and just, you know, kind of made it cute. I was at I really don't remember. I say this every year. I was at a conference or a training or something, and somebody talked about STEM. And so a lot of teachers shy away from STEM because of the big E in it. And for me, doing this dispenser project, that was the focus of the day was the big E. We were all about engineering. Some days it's about the T, where we're really focusing on the programming. In our science classes, it's the S. If you're in a math class, it's the M. But if you can put them all together, then that E sometimes isn't as overwhelming, I guess. Jess, did you want to add?
Absolutely. That big E is really important. And for years, I was struggling with how to incorporate that effectively. And these STEM projects are kind of how I did that. So I was able to use the STEM projects to, I think in the next slide, we have the smart water system. So this is one of the projects that is already all up there. All the teacher pages, the student pages are up there. I initially borrowed the equipment from TI, but I had the calculators. And so we had built a native plant garden in our schoolyard, because for biology, when we study ecology, we talk about our watershed and sustainability. And this was the project that Stacy and I did together so long ago, where I was like, hey, I could do this in my biology class. Like, this isn't just for a engineering class. This isn't just for a computer science class. Like, I could take these elements and use it in my content area. And this project is where that light bulb went off. And I do this project with my students where they have to design a sustainable way to water the actual garden in our schoolyard. So they build a model using these tools where they have to figure out how much moisture, how much, what temperature, at what light level will this water dispenser turn on, this water pump, so that we're not wasting water. We're only using the amount of water that the plants need. So it requires a lot of external research, but then putting all those components together, a lot of teamwork and collaboration in order to get it to work. And like doing this project with my students for the first time, it was amazing because of the communication that they were talking to each other, and they were working together and saying things like, oh, how do we do this? What do you think about that? And like just the types of things that were coming out of their mouth, or like, oh my gosh, this is great. And so it made me want to do more. And then the next slide, I have the heart, the the heart experiment where they set up a heart and they show the electrical impulses of a heart. And I did this after the AP exam with my biology students. And in this particular one, they made an AED. So there's a for loop in which the heart beats and then it stops.
Yo, we did it. We did it. We
And
did
then they
it.
save a life. And they're so excited about that. And so their end of year assessment was they had to research abnormal heartbeats. They had to then change the code to mimic that abnormal heartbeat and then demonstrate what that would look like on an EKG based off of the code that they wrote and the heartbeat that would result because of it. So they had to take information that they were learning and then apply it to how it would come out in this computer program. And it was really interesting. And they did really well with it.
Yeah, this is where you need a partner in crime. We call each other because Jess was like, I have this idea. What do you think about? And so between the conversations about, okay, so this is the anatomy part, this is the physiology part, how do we build the coding? Both of these two projects, we collaborate, but at the same time, we feed off of each other. Jess and I want to create a neuron. We want to create a kidney. We have all these ideas that just keep going around in our heads of how to take now what the STEM team put together and their STEM projects and make it kind of like our own. And what do we want to do with it?
Right. And our final example is something that I came up with. Actually, it was in Baltimore. And I was thinking of how I could do more of these projects after doing the smart water system.
Yes.
And my screaming. We made little trash interceptors. So again, we're talking about how human impact on our local ecosystems, and we are doing trash cleanups in our schoolyard. Well, why don't we build a model showing how we could remove trash out of local waterways? Taking what the STEM team put together and the 10 minutes of code and the STEM projects, I finally felt comfortable enough to be like, let me try something new. And my students were able to be super creative. And if you notice, they built it out of recyclable materials. So we talked about sustainability and what we can recycle, what we can't recycle. So they built their models out of trash. And they also did some PSAs where they talked about sustainability as well. So we built the content along with the engineering design. It was fun.
Yes.
Oh, come on. Yes.
The excitement of the students is just,
it's so much fun.
I know. So we hope you enjoyed this session. Just kind of wanted to give some information in case you are interested in you need help with getting technology, you wanted to try some of the software, you wanted to maybe look at some equipment. Texas Instruments has what's called education technology consultants. And these guys, these ladies and gentlemen, are there for you. They're there for us. Jess and I call our ETCs all the time. But at the same time, they're there to help you get to the resources that you could possibly need. So it's based on the area you live in. And then their names are here and phone numbers. I just wanted to kind of let you guys know that there's more people out there that can help you get the resources that you need. When I was writing a grant, even though it was just from my local area, I contacted my ETC and asked for help.
Yeah. And our Twitter handles are down here too, so feel free to follow us. We always post stuff about the stuff we're doing in our classroom, so feel free to see what we're up to, and we would love to follow you back and see what you're up to as well, because it takes a village to feed off one another and learn from each other. And thank you so much for joining us today.
Yes, thank you so much. Have a great day.
Okay, I'm coming. Here I am. Hey, I couldn't keep up with the chat.
It was
all right. Hold on now. We got a couple things. if you're still with us, and I'll tell these ladies, they probably saw how many were with us. Can we just kind of give like a 3-second standing ovation for these two? I mean, there they are in real life. This is not recorded now. Hopefully you can see them over there on your screen, but um, you can see why these two are in great demand, but mostly in demand by their students, and how lucky a kid would be to have either one of them. I'm just glad they're not in the same school, because that would kind of use up all the talent in one school. So, and here's the mark. I think one of the marks of a great session: the numbers of people that were in your session went up as the session went on. I mean, it was so cool. And I'm kind of checking to see how much time we have here. We have a little bit of time. So I just want to make sure, uh, before I get into the questions that I thought were significant for you guys to address to the whole group. Um, I want to give you an opportunity to say something, if you'd like to, that's not recorded. Look at their smiles. I just love this. These are like two of my daughters. I just think it's great. I love these two. What do you got to tell us?
Well, thank you, Jeff. I am so grateful for Texas Instruments and the STEM team, and like this idea of coding and doing engineering and biology has totally transformed the way I teach. Being virtual this past year has kind of dampened my ability to do some of these projects, but it's really made me appreciate what I've done, and to be able to reflect on what I've done and come up with even better ideas for the future. So I'm really happy to get to collaborate with people like Stacy, because she definitely expands my mind in terms of projects that we want to do together, and it's great.
Mm-hmm.
Yeah, like Jess said, this year was a struggle, trying to figure out how to do this safely. I am hybrid. My freshmen actually come back Monday full time. So we'll all be in the same room. We wear gloves, we wear our masks. I clean and sanitize at the end of the day. But it's a relief, and they have so much fun because, like I mentioned, it's not this huge graded project or assignment or standardized test that they have to do, but their interest in the learning is all based on what they want to do. The last 9 weeks of my course is going to be strictly just projects. And hopefully they have enough skills that they've learned to pull it in. And then my chemistry kids, we've had a little bit. My juniors come back in 2 weeks full time. So I'll be able to spend some time doing some 10 minutes of code with them, and giving some more projects with the hub. So thank you guys.
The hook is embedded pretty deep in you too. I know, with the coding stuff, and you both have some background in biology, and that was my background, and you opened my eyes to some things that can be done within a biology curriculum that really does blend in and dovetail nicely with content items. Just to make sure, I wrote a couple of things down, because I still use a pen and a piece of paper sometimes. The couple of great questions I thought that came up. One of them came up early, like what grade levels would you do this with? And I think if the group was keeping track of the chat, you saw that. These are both, Stacy and Jessica are both high school teachers, but I saw in there, Jessica talking about her son programming the rover. You guys want to piggyback on that grade level thing a little bit, or do we need to just move on from that?
I did a camp last summer virtually, and then 2 summers before with middle through high school students. Middle school students had no problems doing any of this. And I think if you have a student, any grade level, because I know a lot of schools are introducing robotics type programs into K2, K3. If they're tech savvy, they can do some of these as well.
Mm-hmm.
Yeah, and I feel like these types of projects are very low floor, high ceiling, where it's really accessible to any student, especially late elementary school. When I first got my hands on a rover, I brought it home and I was just playing with it. And at the time I had a 4th grader, and he was like, "What's that? That looks like fun." And I just showed him the menu. I was just like, "This is where the menu is. This is how you get the commands to go forward, turn, and that kind of stuff." And like, before you know it, he had programmed to run it around our kitchen island. And it just like I mean, it probably took him like 10 minutes to do. It took me probably like a half an hour to figure out initially, but they're smarter than us already.
On the fear factor teeter totter, here's where people like me are. I'm over here because the fear factor is too great. With a fourth grader, I don't know. I mean, what can you do with a fourth grader? I think pretty much anything they want to do, they can probably handle it. Now, within reasons in terms of their ability to handle things brain wise. A couple other things that I just want to emphasize, and this great thing came up. This new addition to the CX2, Inspire CX2, is Python, which is the new coding language that was built into that. I just want to emphasize again, that is only available on the TI Inspire CX2. So if you have a CX, I don't want to say you're stuck with basic, because that's what this was all about. This was all TI basic that you guys were doing. Is that correct?
Yes.
Okay. The other thing that I thought was great, because Stacy talked about grants, Jessica talked about grants that they've earned. I don't want to say received. You've earned them. You apply for them. And Robin Polson, I need to give a shout out to you, because Robin, you put a link in the chat window for a TI site on the TI website where you can go to learn how to apply for grants. Most teachers don't know the first thing about applying for a grant. They don't know where they're at, how to get them. And I think the grant application process, Stacy and Jessica, has become typically way less tedious, hasn't it? I mean, some of these grants, if you're going to go after $1 million grant, the process is tedious. If you're going after a couple thousand, there are places probably where you live that are willing to foot that bill. Is that correct?
Yes.
Yeah,
My local cable internet provider has a $2,500 grant every year.
Mm-hmm.
Most people don't apply for it. It's non-consumable. So there's grants for consumable materials. There's funds in districts for consumables. This is all non-consumables. And so I got that grant twice. And then I wrote a small, $1,000 grant through a local education foundation and got a bunch of rovers. So yeah, and it's just piecemealing, in the beginning, my school and my district provided the handhelds and the navigator system. I went and found resources to buy the hubs and other parts. If you want more STEM stuff, there's another STEM one called circuits and breadboards after this. And I do some of that in my classroom too.
Yeah, and I did I started with an educational foundation that my district runs that I applied for, and I got $1,700. And I actually reached out to Stacy. It's like, I'm writing a grant, Stacy, help me. And so, relying on your friends is really important. And then also our local electric company offered $500 grants that I had applied for. So again, getting pieces here and there. And now I'm trying to figure out how I can get 20 more CX2s in my classroom to get a class set so I can start doing programming in Python with my students, and just continue going down this rabbit hole of fun, investigative engineering projects in the content area. So I will be also on the hunt for grants and grant writing over the next couple of months in order to supply my classroom for next year.
Something tells me that you're going to get that.
I hope so.
You're not gonna give up until you get what you want. I like that. Ladies, I need to move on a little bit here to our next slide. Hopefully, maybe. Here we are. There we go. Just to wrap up today, here's some events that are happening. You don't need me to read this to you, but there's some really important things on here. Like if you want to win prizes, this thing is a pretty big deal. There's trivia questions and a leaderboard on the T-Cube IC Challenge. Remember that the keeping the conversation going on the Slack site. Is it called a Slack site? That sounds kind of lazy, a Slack site. That kind of sounds like my kind of place. But a couple other things here today. We have some sessions that we're highlighting here. Birds of a Feather, which is a short one this afternoon from 3 to 3:30. I believe that's Central Time. Lots of other coding, CAS, STEM engineering things that are going on. And I'm interested in this one, not because I'm interested in yoga, which really disappoints my wife, but math yoga. This is next Saturday. So 9 o'clock in the morning, which if you live in California or the West Coast, that's 7 a.m. Perfect time of day, I hear, to do yoga. and Kate the chemist and 7 for 7 ideas and all that kind of stuff. There's just loads of stuff that is going to be available to you, not only for the rest of today, but also for next Saturday. So let me be the first and the last to say, face to face, thank you, ladies. You guys are awesome. You're two of my heroes, and I'm so proud of you. You guys did a great job today. So thanks for joining us, everybody. We'll see you in another session.
Yes, thank you all for being here today. Let us know if you have any questions.